Hello, here is 2.5, solving equations involving absolute value. Here's the why. Absolute values create the world we navigate. They help us make mistakes and set boundaries. What we're going to see that absolute values establish are the concepts of a boundary on the left and a boundary on the right. Doors, for example, use this because the doorway is a certain width open. Right? You have a certain amount of space to walk in between a door. Driving lanes for cars, have a left point and an end point. Making a sports shot like a field goal. You are shooting between a left boundary and a right boundary. And then acceptable ranges, such as I need to score between a 70 and an 80 on this test or midterm exam to keep my A. So the concept of this is also an absolute value. At this point, I encourage you to think about what are some of your own examples to maybe where you have some type of boundaries, and it can be time, such as between 4 and 5, right? Maybe that's when you eat a snack. Or you can do it in terms of sports. Because soccer goals, have boundaries left and right, as well as up and down, right? So just think about ways in your own life where you experience, kind of a starting point and an ending point in terms of a boundary, because that is absolute value. What is absolute value? Absolute value is distance from a center point. That's, in a sense, what absolute value is all about. There's going to be a middle point and then space to the left and space to the right that creates an absolute value from that center point. Here's how they work mathematically. It's going to revolve around the concept that distance is always positive. And if you think about that, you might be a little confused what that means. If you're measuring the distance between you and, say, a friend, say for the 6 feet restrictions for the pandemic, 6 feet in one direction, is a positive 6 feet. If someone is 6 feet in another direction, you wouldn't say that they are negative 6 feet away from you. They're just 6 feet in a different direction. So there's no way to get out a tape measure and measure something and say that's a negative something inches, right? Distance is always positive. So what that means is that when you see absolute value bars, right, which are going to be bars like that, they're like parentheses that don't curve, you're always going to get a positive answer. So if your answer already was positive, it stays positive. If your answer is negative, it also turns positive. So it will always yield a positive number. And here's an example. This is saying evaluate this if f is equal to -9. So when I go to use the absolute values and they operate like parentheses in terms of order of operations, we get -9 plus 7 to get a -2. Now, the absolute value of -2 is going to become a positive 2 because those bars are saying absolute value, which means what's the distance from a center point, in this case 0, and we'll learn more about how to move that center point later. -2 is 2 spaces away from 0, so the absolute value of -2 is positive 2. And then when I bring down that subtract 11, we end up getting an answer here of -9, right? Which you might be saying, I thought you said that these answers would always be positive. Well, that's for the absolute value component, and it certainly was. But then if there's other numbers on the outside, anything can happen at that point. But as far as the absolute value component, it will always be positive. Here's a picture of what we're going to be able to take care of after we go over this lesson. We will be able to write an absolute value that fits the solution graphed below. So I'm going to be able to, by the end of this video with you, write an absolute value that leads to the solution of 10 and 16. We'll also be able to do it with situations like this. And this is one to where you could probably think about this logically. Engineering, tolerance in engineering is an allowance made for imperfections in a manufactured object. The manufacturer of an oven specifies that the temperature tolerance of, and this symbol here is called plus or minus, which means it could be off by 15 degrees in a positive direction or a negative direction, means that the temperature inside the oven will be within 15 degrees of the temperature that it is set on. Write and solve an absolute value equation to find the maximum and minimum temperatures inside the oven when the thermostat is set on 400 degrees. We can come back and write this equation, but as far as it goes for conceptualizing these, they're not that bad. So if we see this here, we have, if it's set to 400 degrees, that plus or minus means we could add 15 to where if the oven's reading 415, that's still a properly manufactured oven. If it's reading 385, because of a subtract 15, that oven is still working at an acceptable level. So we get a range here between if they make an oven and they set it to 400 degrees and it registers anywhere between 385 and 415, that's an acceptable oven. But, an example would be if you set it to 400, it thinks it's at 400, but you measure the temperature and it's actually at something like 350, that oven would not be acceptable according to the engineering requirements. We'll come back and write the equation for this to kind of see how to generate these numbers if we wanted to do it mathematically instead of just thinking about it logically. And then also situations like this. A certain scholarship and student loan fund uses a formula to determine whether or not a student qualifies for college funding. This formula is absolute value of 3K plus 6 equals 15, where K is a need score determined by an interview. So they'll ask you different questions and determine that if you are eligible for the loan or not. And so it's asking, what are the possible need scores? We will return to this one once we see how to solve absolute value equations. Here is how you solve an absolute value equation. The first thing that we need to consider is that there is going to be two solutions. Because of that plus minus situation, or the concept that, distance from a center point is going to go in both directions on a number line. So that's something that we have to factor in right away, is that we are expecting two solutions. And what you do is once and this page is already easier to where everything's already simplified for us. So this will change a little bit later. But if we have an absolute value is equal to a number, the way that we're going to solve it is that we're going to split it into a positive case and into a negative case. So if we have the absolute value of x is equal to a number, we're going to split it off into the x is equal to the positive version of that number and where x is equal to the negative version of that number. And that's going to tell us the two different solutions. And this will make some more sense once we see it on a number line. So what does the graph of the solution show us? It shows us distance from the center point. So let's try some of these. Solve each equation, then graph the solution set. So this is the absolute value of y is equal to 3. And what we'll see is if there's no other numbers inside the absolute value, so we just have the variable, our center point is going to be 0. And we could also see this by splitting it up into y is equal to a positive 3 and y is equal to a negative 3. And when I graph those, we'll see that the center point is in fact 0. Right, so I'll just highlight it because it actually wouldn't show up on our graph. But the absolute value of y is saying, hey, find me 2 points that are 3 spaces away from our center point, 0. Now, when there's numbers on the inside, that's going to move our center point. And it actually doesn't work quite like you'd expect, because you see that -4, you might be expecting a center point of -4, but then you look on the number line and there's no negatives at all. And let's see why. So what I'll do is I'll take x minus 4 and I'll set it up equal to the positive 4, and I'll take x minus 4, and remember I'm talking about this 4 right here. Because off this template we need to split it up into the positive version and the negative version. So we're also equal to a -4. And then when I go through to solve, we'll get that x is equal to 8 and x is equal to 0. And I'll plot those on my number line. So here we have 8, here we have 0, which you might then notice, hey, does that then make the number that's in the middle the opposite of what number was previously shown inside that absolute value? And that is in fact the way it works. Right? So if you take a look at this graph visually, you can see that the number in the middle is a positive 4, which is the opposite of what you might expect. But let's try another one to see if that kind of holds true. Here we have y plus 3 is equal to 2. So when I go to set this one up, we have y plus 3 is equal to a positive 2, and y plus 3 is equal to a -2, because I needed both the positive and negative version of that 2. And then we'll solve. And we'll do that and get that y is equal to -1, y is equal to -5. And when I plot those, you will in fact see that the number that's in the middle is a -3, which is the opposite of what the number you see there in the absolute value. So the way absolute values work, so we'll come down here, is this. This is the format for writing absolute value equations based upon graphs. And we're only going to be looking at easy graphs so far. This formula works on the easy setups. But we talked about that concept of where the number in the middle is the opposite of what you might expect. And that's because this formula brings its own negative sign. All right? So that's what causes things to appear as opposites. It actually has nothing to do with the fact that we're dealing with absolute values. This concept of using x minus is going to be very common throughout the year. We'll see it in multiple different formulas. And that subtraction sign instead represents the difference, because we're tracking from a center point. So to find that distance, we use subtraction. So whatever number you see here, this number represents your center point. But you have to keep in mind, you'll be tempted, based upon that subtraction sign, to think of it as the opposite of what it should be. So up here, we had, x minus 4, but our center point was the positive 4. Here we had a positive 3, so our center point was a -3. So it ends up being the opposite of what you might expect. This number out here tells us the distance from the center. Right, so what does that mean, Mr. Cottle? Notice on this one, our number was a 2. So that 2 represents the distance from the center point. And if you look, this is 1, 2 spaces away. 1, 2 spaces away. If I come over to this one, our value is 4. And notice that it's 1, 2, 3, 4 spaces away. 1, 2, 3, 4 spaces away. And then the x is just our variable. So the variable is what denotes that we're going to be working with an equation. So this is the formula that we'll use. The number on the inside tells us the center point. It's going to appear opposite of what you'd expect. The number that we're equal to is the distance from the center. So let's use that to write out equations for these guys here. So essentially our absolute value template is going to start like this, and we're going to fill in these 2 spots. Now, let's first look and notice that our center point is a 0, so I'll put x minus 0. And then the distance from that center point in both directions is 4. Now, if you're saying, hey, Mr. Call, that's only 2 spaces. Well, if you look, they're counting by 2s. So this is 4. So that graph, number line graph, could be modeled by the absolute value of x is equal to 4, which is really saying plot 2 points that are 4 spaces away from a center point of 0. And all of these can be written by using that generic formula and then filling in your 2 values. So here, our center point is a 1, and the distance is 2. So that would be the absolute value equation for that situation. And then for this one, I encourage you to give it a try. So find your center point. So it looks like -3 is my center point. And then the distance that took me to get there was 4 jumps. So I could go ahead and change that double negative to get this as my final answer. And then as for the solving, to come back to it, remember that the key concept is to set up what's inside your absolute value equal to both the positive version and the negative version. So whenever there's a number out in front of x, that's the beginning of our formula starting to get a little bit messed up. But we can still solve this one by hand, no problem. So that formula that we learned down low works on the easiest type where there's no value with x, right? When there's nothing out in front here with x, it's just an invisible 1. That's when this formula works. But as for this one, there's a 2 with the x, so we can still solve it. But notice that, this 8 no longer represents the distance from the center point, right? Because our distance from the center point is, in fact, 4, which is that 8 divided by 2. And the concept gets even more mixed up when we have like a 5 with the y and then also a number, because this -2 is not going to make our center point a positive 2 because of that number out front. That formula that I gave you down low is for the most basic type of absolute values. But to solve this one, we take 5y minus 2 and set it up equal to 7, and 5y minus 2 is equal to -7, and solve. So we get that 5y is equal to 9, and 5y is equal to a -5. So we get that y is equal to -1, and y is equal to 9 over 5. which is a 1.8. So this one's center point ends up being a fraction. You can kind of see that middle point would be somewhere in there. And if you're very curious about, how would I then identify that center point, you don't need to know this right now at the Algebra 1 level, but the way you would do it is you would take this number and divide it by that number. So if you do 2 divided by 5, you get a 0.4. And if you look at our graph, that does, appear to basically be right there at 0.4. And you could use that on this one too, because it's really a 0 in there. And if you do 0 divided by 2, you get a center point of 0, which is what happened. But you guys don't need to know that at this point, but it's just something I wanted to point out to you all if you're curious about how to find the center point when the formula that we learned about doesn't work, because this formula only works when we have a 1 out in front with our x. So here for number 9, this one's special, and here's what it's trying to teach us. I have the absolute value of something is equal to a negative 0.6. So when you see that, that might cause some alarm because you're saying, hey, Mr. Cottle, this is an absolute value. I thought you said this could never yield a negative answer, and you are correct on that. This one has no solution. Right, and you could try to solve it out, but if you go back and plug in the answers, you'd end up getting a scenario that doesn't work. So let me show you what that means. So if I went ahead and did p minus 0.2 is equal to a negative version, and p minus 0.2 is equal to a positive version, and I solve, by adding 0.2 and adding 0.2, we'll get that p is equal to a negative 0.4 and p is equal to a 0.8, which might be saying, well, Mr. Cottle, I got answers. Why can't I graph them? If you try to plug these back in, so either one of them, I'll just do the positive one to make it a little easier. You end up getting inside your absolute value, the absolute value of 0.6, and it's trying to become a negative 0.6, and it just can't happen. So this is a term that we use later on in mathematics, but these guys are called, if you're curious, extraneous solutions. And what that means is it's solutions that you can find on paper, right? We found them by doing math, but they don't actually work because the problem has no solution. And when you try to plug them in, like right here, when I tried to plug in the 0.8, I get a situation that isn't actually possible, and that's called extraneous solutions. So back on this, as I mentioned, we would now be able to write out the equations that match this number line. We could solve this college problem, and we could write the equation for the engineering one. And that's the one I'll start with is here first. So what I would do is I'm going to set up my absolute value. I'm going to set up my variable x, subtraction sign. Our center point is 400. And the distance from that center point is 15. And notice what happens if I solve this. X minus 400 is equal to 15. X minus 400 is equal to negative 15. When I go through and add 400 onto both sides, I get 415, and I get 385, which were the two solutions that we found by just thinking about it logically. But now we also have the ability to set up the equation as well. For this one, when we go to set it up, we would recognize that that center number is 13, and the distance from it is 3 units. So we put our 3 there. And then finally, a certain scholarship and student loan fund. They've given us our equation. So this is one where I would not be able to make a graph and call -6 my center point and 15 the distance because we have a 3 with the k. But we could go ahead and get this solved. So we'd subtract 6 from both sides. And then go through and divide to solve. So we then see that we get scores here of -7 and 3. So if you scored anywhere on this interview range of where they ask you questions and you rate between a -7 and a 3, you would be eligible for the tuition and the scholarship. And if you're wondering how to find the center point, you would just do that formula I described earlier, which you don't need to know this. But that 6 is actually a -6 because of that opposite concept. So this tells us that our center point is -2. And this wasn't even asked, but I just kind of wanted to show it to people. And that gives us a distance here of 5, and there another distance of 5. And that would just kind of let us know that we have a 10-point range here of scores. And you just have to score between -7 and 3 on their survey or the interview to be eligible. So this section's definitely one of the more complicated ones that we look at in this first quarter. So you may very well have questions. There is a second part that we'll check out additionally as well. And you can always go back and rewatch this one too if you needed more practice. But we'll continue the second part together in class.